Hello all! In this video I'm going to show you how to develop applications for the all Macintosh system like System 6 and System 7 using a modern development environment. The development environment I'm going to use is CLion. It's a very powerful development environment for C and C++, and this feature will be achieved thanks to the Retro 68 compiler. The Retro 68 compiler, that you will find a link in the description, is a GCC-based cross-compiler for classic 68-key and PowerPC Macintoshes. You should read the README file before starting with it, because it has some dependencies that you will need to have installed, and also there is a difference between the Apple Universal Interfaces and the Multiversal Interfaces. As you probably know, when you're compiling, creating software, developing, you need some libraries and you need to know what functions, methods, etc. are exposed by those libraries. In the case of our Macintosh system, this set of include files were integrated in the Macintosh Programmers Workshop and was called the Apple Universal Interfaces. These interfaces are free to use, however they are not free to distribute. You can download them on certain sites. They are in the README of the Retro 68 project, and doesn't seem that Apple really cares. But this project has created a set of interfaces that, while incomplete and not including basically anything after System 7, they're pretty usable right now. They're called the multiversal interfaces. I'm not going to explain how to use the universal interfaces. I'm just going to go with the default multiversal interfaces, but you're free to modify my instructions to suit your needs. You can also do it on Windows using Cygwin, but it's kind of not a good idea. Better to use Windows Subsystem for Linux in this case. The first thing to do is to clone the repository in a workplace, a place we can work with it. So I'm just going to my drive here, and it's very important that we do a recursive clone because it has several subprojects. Once cloning has finished, you should choose a place to store the compiler result of Retro 68, the compile toolchain. In my case, I'm going to choose /upt because it's the designated place where things that are installed outside of the distribution package manager usually go. Once you're there, you follow the instructions here, just as simple as invoking the command to compile the toolchain. So I'm just going to the place, and then I'm going to invoke the script to compile it. And just sit and wait, because it's going to compile GCC. It's going to take a long time. While you're waiting, you can read the whole of the documentation that is tell you the accessory tools, like for compiling resources, for launching an application using an emulator, converting object formats from, for example, you may have a library from original Apple systems compiled by Macintosh Programmers Workshop and you want to link it, so you need to use the convert object. Or you also have a console library, because in all Macintosh system there was no console, no terminal concept, so this had to be implemented by the compiler itself, usually the compiler suite. For example, CodeWarrior uses Sioux, so Retro 68 had to implement their own console. They also have some examples on how to use it. now that everything has compiled, it's time to open CLion and integrate our new toolchain Retro68 on it. We can see here that it has some CMake toolchains. This is what we're going to use. So let's open CLion. Create a new project. It's going to create a standard C library. I'm going to call it Retro68 Hello. I'm going to use C99 or even C11 because we're using the latest GCC compiler, so we can choose modern language standards. We can also use C++, but for all of the other project types we really cannot use it because there's no QDAR, no Qt, and so. But you can use C99 or you can use C++ and use even C++20 because it's a modern version of GCC. I'm just going to use C99, call it Retro68 Hello. I already had a project with this name, it's just a hello world, so no problem. I'm going to take a look at the CMake lists. I'm going to put a message here, so when it's configuring, it tells us the system name. Now I'm going to reload the changes. You see it says Linux, because that's what's currently configured. Now I'm going to go to File, Settings, Build Execution and Deployment, and Toolchains. Here I'm going to add a new toolchain. We can manually put here the C and C++ compiler, or if we install Retro68 on a Docker or on a remote server, like for example I have here for MacOS or for Haiku, but cannot connect right now because I'm not on that network. But you can set a Docker with SSH and it will use it. Because it's locally, I'm going to leave it on default. It's not going to use this version of Make and CC anyway, because here I'm going to create on CMake a new one. I'm going to call it Retro68 M68 key, type default. Now I'm going to do -d CMake toolchain file equals, and here we can see the toolchain files. So I'm going to see which one is for Motorola 68 key. So Retro68 toolchain M68 key CMake, and here it is, Retro68 toolchain.cmake. So I'm going to copy this URL here, and then the toolchain file name here. Now apply this one, and now it's going to reload the CMake. So we have the debug was created by default Linux, and we have Retro68 key. Remember the system name now is Retro68. So now if I come here and choose this and build it, it's going to build it for Mac. So I can see here, here it is as a Mac file with the resource fork and the firmware info and the Finder info, sorry. And we can do the same for PowerPC. So I'm going to come here again on CMake. So I'm going to duplicate this one, call it PowerPC, and then use I think was PPC or PowerPC or PowerPC. So PowerPC, and I think it was Retro PPC, and let's check in case. Yeah, Retro PPC. Now I'm going to compile it. Sorry, rebuild the CMake cache, which I can CMake here. Now we have that the system name is RetroPPC. It doesn't set up the processor name, so you should, if you're using CMake, detect the system name is RetroPPC and consider that it's PowerPC. I'm going to build it now for PowerPC, and here we have it, built for PowerPC. There's enough in the info resource for because as a PowerPC application is in the PEF format. So if I copy here the path, copy path here, absolute path, and do file. It seems that's not linked properly. There is also a new option added to CMake that you can see if we come here and look at the examples that are already on your toolchain folder anyway. And we look at the samples here on the hello world. We can see on the CMake that they have not only done this add executable, but they have used add application, because this is a macro that will ensure it creates the proper format. So I'm just going to put here add application, and I'm going also to add the console library as in the example. Now I'm going to run out the change. I don't know why it's not working. I think that it's kind of tricky. It has some requisites about what you define for project and so on that are not exactly CMake compliant. Okay, so now you see the CMake for Linux is failing because it doesn't recognize that application. What I do on bigger projects is when I detect that it's Retro68, so instead of declaring a project, and I use the add application, and in the samples folder you have many more samples on how to add a window definition, how to use a resource, compile a resource, and more complex examples here. Now if I compile for PowerPC, now it's going to link the executable and create a proper format. Saying if I compile here for Motorola, it's going to create a Mac binary file now. There is also one very interesting thing that you can target Carbon. So same as we have here PowerPC, RetroPPC toolchain, we can just add RetroCarbon toolchain. And this will generate a PowerPC executable linked with the Carbon library for macOS. So the Carbon library was one library that was introduced with macOS 10 and also working on macOS 8 and up. That basically recreated all the original application programming interfaces from macOS inside the library, allowing you to execute the same application, exactly the same code, both on macOS 8 and up and on macOS 10. So macOS 10 will run natively, like a macOS 10 application, while on macOS 8 or macOS 9 will run as well natively using the Carbon library. The Carbon library is still very easy to download and allows you to create hybrid applications that for macOS 10. Obviously for PowerPC macOS 10, Carbon doesn't really work on Intel. This is a discussion for another time. But in a nutshell, the application is going to compile for PowerPC anyway. I mean, you can get Carbon and port that application now to macOS 10, to Intel macOS 10, 32-bit Intel macOS 10. You cannot do it for 64-bit Intel macOS 10 or for M1 macOS 11 anyway. So now we have RetroCarbon, and if we compile it, we have the executable. One very interesting thing is that you can use the launcher that's described here in the documentation to automatically configure and launch an emulator with your application. Obviously, you cannot debug it using CLion because CLion expects to use the GDB debugger, and inside the emulator you will have at most MacBugs. But it's good thing to have because you can launch the emulator automatically with Macbugs and then do the debugging in Macbugs. So that's all for today. This is the last video I'm going to do for Macintosh. I didn't have time for more, but I still plan to do more videos showing software and games for MacOS and running on real MacOS hardware, as well as on the Fusion emulator I showed in my previous video. Thanks for watching, and please don't forget to subscribe. Bye!